Our Earth has always been a stage for some of nature's most astonishing spectacles. But few are as strange or terrifying as the age when enormous insects ruled the skies and forests. Today, we know over 1 million insect species, with countless more likely undiscovered. Most of them are tiny, many no larger than a grain of rice. Some, like fairy flies, are as small as a human hair. But millions of years ago, long before humans or even dinosaurs, insects weren't always this small. Roughly 300 million years in the past, during the late Carboniferous and early Permian periods, our planet entered a rare window in time. During this chapter of Earth's story, the perfect mix of environmental conditions allowed some insects to reach monstrous sizes, giants that have never been matched since. Back then, Earth's continents were slowly inching toward one another. This slow-motion convergence would eventually form a colossal landmass called Pangaea. As land collided and merged, ancient climates began to shift. But for a brief period, the world was warm, lush, and incredibly humid. An insect paradise. One of the most important ingredients in this prehistoric recipe was oxygen. During the Carboniferous period, the planet's oxygen levels reached unprecedented heights, up to 35% compared to today's 21%. With such rich air to breathe, many terrestrial and marine organisms flourished. For insects, especially those that rely on passive oxygen diffusion, this meant more energy and the potential for enormous size. Among the giants of this era was Meganeuropsis permiana, a flying insect that resembled a modern dragonfly, but on steroids. Living about 290 million years ago, Meganeuropsis had an estimated wingspan of 71 centimeters, more than 2.3 feet across. That's nearly 5 times the wingspan of today's largest dragonfly species. To imagine something like this buzzing past your head is to glimpse a forgotten age of nightmares. Meganeuropsis wasn't actually a true dragonfly. It belonged to an extinct group known as griffinflies, which shared many dragonfly-like features but had notable differences, especially in the structure of their wings. These predators likely hunted by swooping down on other insects, snatching them mid-flight with long, spiny legs, and devouring them with powerful jaws. Their enormous compound eyes gave them panoramic vision, perfect for tracking tiny movements in thick vegetation. Some researchers believe they also hunted small amphibians near swampy shores, creatures like temnospondyls, which were common at the time. The remains of Meganeuropsis were discovered in what is now the U.S. state of Kansas. But 290 million years ago, this region was a patchwork of inland seas, slow-moving rivers, and flooded wetlands. Dense tropical forests dominated the landscape, filled with ferns, horsetails, and towering tree-like plants, such as calamites. These forests created a perfect hunting ground for aerial predators like Meganeuropsis. While it was the biggest insect ever found, Meganeuropsis wasn't alone. Another large prehistoric flyer, Mazothyros enormis, shared similar habitats. Though not quite as massive, with a wingspan of 56 centimeters, it too dwarfed any modern insect. This species had an odd appearance, with additional flaps on its thorax and a piercing mouthpart used to feed on plant juices. But insects weren't the only arthropods to grow massive in this age of giants. Giant scorpions, oversized spiders, and massive relatives of millipedes also thrived. One of the most impressive of these was Arthropleura armata, a colossal myriapod that could grow over 2.5 meters long. That's longer than most humans are tall. Despite its fearsome appearance, Arthropleura was not a predator. Evidence now suggests it fed on plant material, moving slowly through forest floors and devouring leaves, fallen wood, and decaying organic matter. When first discovered, it was imagined as a nightmare predator. But the truth is much more surprising. It was a peaceful herbivore, though no less terrifying in size. So, What happened to all these oversized arthropods? Their reign ended gradually. As the Permian period continued, global conditions began to change. The climate became drier, especially inland. Rainforests shrank, oxygen levels dropped, and Earth's ecosystems grew harsher. Insects that had once soared above tropical wetlands now struggled to survive. At the same time, the first large land-dwelling vertebrates were emerging, including the ancestors of mammals, reptiles, and birds. These creatures had more advanced mobility and better hunting tools. Giant insects and arthropods, once rulers of their ecosystems, became vulnerable. They were too big, too slow, and too obvious. Many went extinct. Others gradually evolved into smaller forms that could better survive in changing environments. The age of insect giants faded into myth, until only fossils remained. And then came the final blow. Roughly 252 million years ago, the Earth was struck by its most devastating extinction event, the Great Dying. Triggered by massive volcanic activity and runaway climate change, this event wiped out nearly 90% of marine species and 70% of life on land. The remaining large arthropods were lost forever. In their place, smaller, faster, more adaptable species took over, eventually giving rise to the world we know today. But for a brief moment in Earth's long story, the skies buzzed with giant wings, the forests crawled with colossal centipede-like beasts, and the air itself allowed life to become larger than we can imagine. It was the age of the insect titans, a time of wonder, danger, and strange beauty. And though it has passed, their fossilized legacy reminds us how dramatically life on Earth can change.